Hey math kids, we're going to talk about the modulus and the argument. So the modulus is just the length of a complex number if we think of it as a vector. So it's the magnitude, essentially. If we're thinking of z as a plus bi. And then if we had this drawn and we measured this angle, then that's going to be called the argument. So modulus is length, argument, or argz, would be theta. Okay? Now we're just going to jump right in. So if we're given 1 plus 3i, we need to find the modulus and the argument of that. So to find the modulus, we're going to do 1 squared plus 3 squared square rooted. So 1 plus 9, or 10. So that's the modulus. Okay, now to find the argument, we need to draw this. So 1, 1, 2, 3. We're just going to look at it like this triangle. We know that this side is 1, this side is 3. And so theta, we're going to use tangent theta equals opposite over adjacent. And so we just need to do the inverse tangent of 3, and that will give us theta. Okay, so inverse tangent of 3, we want to be in radians, and so inverse tangent 3, so that's 1.25. Okay, the next one, negative 1 plus 3i. So that's just going to be negative 1 squared plus 3 squared square rooted, 1 plus 9. So that's also the square root of 10 for our modulus. And then if we want to use the same pair of axes, we're just going to go this way, which is negative 1, 3. And the measurement of the angle is going to be this. And so I think the way that I would approach this, I would think of it as this rotation is going to be pi. And then I'm going to subtract out this same angle, which would be this, which is 1.25. So if we do pi minus 1.25, I get 1.89. And the last one, negative 3 minus I. So that's going to be negative 3 squared plus negative 1 squared, which is 9 plus 1, which is square root of 10 again. Okay, this time we go, let's see, we go 1, 2, 3, and down 1. That, and we're rotating from here. So if we have 3 and we have 1 and we're trying to find that, it's going to be inverse tangent of 1/3 this time. And what we're going to do, that's going to give us just the angle from here to here, and so we'll do pi plus that angle. So if we go here, inverse tangent 1/3 plus pi, we're at 3.46. Ooh. But I left something out. So our angles have to be negative pi to pi And so I actually can't measure it that direction. Instead, I need to think of this entire thing as negative pi, and so I should be doing negative pi and then backtracking. So negative pi plus the angle that I have, because adding would be backtracking. I know that's kind of confusing. So negative pi plus 0.321 or 0.322. And when I do that, negative pi plus 0.322, I get negative 2.82. Alright, so don't forget that like I did for a second, but that's how the argument needs to be measured. Okay, so they want us to prove that this is true for all complex numbers. So z1 we're going to say is a plus bi, z2 is c plus di. So if we plug that in right here, we're going to a plus bi times c plus di. Okay, over here we need to multiply ac plus adi plus bci plus bdi squared. Then over here we don't change anything yet. Okay, so if I add those together, I get AD plus BCI. That's a negative 1. So then I get AC minus BD. Those are added together, and we're still taking the magnitude. Okay, so to do the magnitude here, we're going to do AC minus BD squared, square root, and then AD plus BC squared. And if we do that, we get A squared C squared minus ABCD minus ABCD, and then plus B squared D squared. So that was just that piece. And then it's going to be A squared D squared plus ABCD plus ABCD plus B squared C squared, which this cancels this and this cancels this. So we have A squared C squared plus B squared D squared plus A squared D squared plus B squared C squared. Alright, so that's one side. Now if we come back up here, we find the magnitude here, so we're going to say A squared plus B squared square rooted, and then we're going to say C squared plus D squared square rooted. And when two things are under square roots, you can multiply them and still keep them under a square root. Oh, by the way, these are still under square roots. Okay, so we multiply those. A squared C squared plus A squared D squared plus B squared C squared plus B squared D squared. I believe those are the same, so this is under square root. Okay, those are there. BD, BD, AD, AD, and BC, BC. Alright, so they are the same.